So I think the recording is now set up. So let me share the screen, then we can proceed. Can you confirm that you're able to see the screen, my screen?
Yes, I'm able.
Okay, so I hope it's clear to everyone. Okay, so we'll go into solving the problems immediately so that we can finish early and people can take a break. So here is the first question. It says 3 points are chosen on the sides of a triangle and then connected to each other as shown in the figure below. So some of the resulting segments have been given equal length. So the task is to prove that A will be equal to C. This should be not too hard. Maybe I can give the audience a minute or two to see if you can come up with some ideas on how to solve this. If you come up with any early, you can feel free to share. You can just unmute your mic and share. So I'm Dr. James Katende from the School of Mathematics, University of Nairobi. In case there's anyone who doesn't know me.
Con earphones.
Hello? Any ideas so far? So the diagrams are also not drawn to scale. So you can't trust the diagram completely. Don't rely on the diagram, just rely on the properties of the triangle. So maybe we can go to the solution, or is there anyone who has some ideas? So so I'll move on and to the solution. You can probably check to see if you had the same ideas we will use in the solution. So here is the diagram, the same diagram again, but now we have labeled it. We've labeled the corners and the vertices of the triangles. So we can make the following observation. These two triangles, BC1 and A1. So BC1, A1, and this other triangle, CA1, B1, they are congruent. We come to that conclusion based on these three sides of a triangle, of two triangles being equal. Because you can see here we have B, we also have a B here, and then we have two C's and another two C's here. So these two triangles are congruent. So now when we also look at the angles, for that reason, we can conclude that these two angles, C1B, A1, so this C1B and A1, this angle here, and the angle A1C and B1, that is this angle here, those two angles, we can conclude that they are equal. So that tells us that this triangle must be an isosceles triangle with AB is equal to BC. So if it's an isosceles triangle, it means if this side AB is equal to BC, then we can do the following. We can say that the length here, B plus C, should be the same as the length here, A plus B. So now from this, it's easy to conclude that A must be equal to C. And that solves the problem. Any questions on this? Can you hear me?
Yes, yes.
Oh, good. So there are no questions on this, but you can always bring us back to this question. If something comes up along the way, you can always bring us back here. So I'll go to the second question of the day. So here is the second question of the day. Again, today we have more geometry. This is another geometry question. So it says the following: in the figure below, a triangle ABC is isosceles with the two sides AB equal to BC. So we have a point X, which is on the extension of this segment MN on the side of N, right? And we also pick a point Y on this segment NX, and we pick it such that these two lines, MN, these two segments, MN and this XY, are of equal length. So the task here is to prove that BY is equal to CX. So again, I can give you a few minutes to come up with some ideas on the way, on how to solve this. As usual, if you get some ideas, you can always just unmute your mic and share. Also, remember the diagrams are not drawn to scale. So do not trust the diagram, just trust the properties of the geometric objects. Today there's a lot of silence. There are no ideas. Anyone who has come up with any ideas? You don't have to solve it fully. You can even just share some ideas you have, then we can go to the solution. Any ideas? Okay, so now we can move to the solution. And if you had started solving it, you can compare and check again if you use the same techniques or ideas. As usual, there may be more than one way to solve these problems. So what appears here is just a suggested solution. You can hear me? It's a bit too quiet, so maybe it's good to confirm that you can hear me.
Yes, yes, clear.
Okay. So here we go. So we have moved with the diagram as well. So let's see what observations we can make. So we know that AB is equal to BC, and we also know that M and N are the midpoints of the two sides, AB and BC respectively. So that forces the following, that this length, since it's just half of the side of this triangle, BM must be the same as CN, because again, CN is just half of the other side of the isosceles triangle. So we can conclude that BM is equal to CN. That's the first thing we can observe. Now, based on that, we can make more observations. Now, this length from M to Y is given by MN plus NY, this distance here. We also have the length from X, from X to N, which is given by XY plus NY. But we know that XY and MN are equal. So that forces these two lengths, MY and NX, to be equal. So now we know that this length from here, M to Y, and the length from here, N to X, those two are equal. I think we are together so far. So, yeah, so so that means the following angles will be equal. BMY, which is this angle here, should be equal to BNM. That is because this triangle BMN is also an isosceles triangle, so these two must be equal. Then we have that must be equal to this angle here, which is vertically opposite, CNX. So these two angles are, these three angles rather, are equal. So now you can compare these two triangles, BMY and CNX. And now you'll observe that those two must be, they must be congruent, because we are using this, the side, two sides and an included angle rule. This confirms that the two triangles are congruent. I think we are together up to that point. By now you must be able to guess what the next step will be. So if they are congruent, then it leaves you no option but the fact to conclude that BY must be equal to CX, because that's the only side we haven't looked at. The other side, MY, is equal to XN, so that is covered. Then we have BM is equal to CN, so that is covered. So the only side remaining is CX and BY, and since the two triangles are congruent, those two sides must be equal. Is that making sense?
Yes.
Yes.
Okay. So if there are no questions on this one, I can move on to the next one. So here we move to some number theory. Maybe this one might have a little more activity. So the question number 3 says the following: the product of 3 different divisors of a positive integer n is equal to 14 raised to 600. So our task is to find the smallest possible value of n. So again, I will let you play around with this for a few minutes, maybe 2 minutes or 3. Then we can look at the solution. As usual, if you have any ideas you can share, just unmute your mic and share. Any ideas so far? When you are ready to share, simply unmute your mic, then you can share the ideas. Yes.
Hello?
Yes.
So the integer n has 3 different divisors. So I have them as A, B, and C. And then
Yes.
their product now ABC is 14 to the power 600.
Yes.
So my approach is to try and split this 14 to the power 600 into, I have it as now 2 to the power 2 times 7 to the power 600. So I have 2 to the power 600 times 7 to the power 600. And now I don't, my idea is just that one of the divisors is a power of 2, another is a power of 7, and the other one is either like 2 to the power, either a power of 2 or a power of 7. But I don't know. That's why I've reached. So.
Okay. Anybody else with a different idea, or to complete the shared idea? So thank you for sharing. I think that is good when we are active like that. So let's look at the solution. Then you will see how far you had gone. So we have the 3 divisors. We call them X, Y, and Z. And since they are divisors of n, then we can write them as quotients: n over A, n over B, and n over C, where A, B, and C must be different numbers. They must be different because X, Y, and Z must also be different. 3 different divisors. So A, B, and C are also factors of n. Now, we can manipulate this. If you multiply X, Y, and Z, which is a product of the 3 factors that we are looking for, it should be equal to n cubed over ABC. And that product also, we have been told, is equal to 14 raised to 600. So using this equation here, we can rewrite it as n cubed is equal to 14 raised to 600 multiplied by ABC. So at this point, you realize that you have a perfect cube on this side. This one also is a perfect cube. So that forces this product of A, B, and C to be a perfect cube, right? So A, B, and C must be a perfect cube. So the other thing the question is asking is for the smallest possible value of n. If you're looking for the smallest possible value of n, then we should also look for the smallest possible value of this product of A, B, and C, with a restriction that that product must be a cube as well. Can you all see why this product must be a cube?
Yes.
Yeah. So now the smallest possible cube you can consider is 1. So you start from there. But when you consider, so this is just restating what I had said. If n cube becomes smaller as ABC becomes smaller. So our problem is basically reduced to finding the smallest possible value of AB and C, the product of AB and C. So we can try, again, that repeats what I just said. The product must be a perfect cube. Now, the smallest perfect cube we can think of is 1, but this will not work, because if AB, product of AB and C is 1, that forces all the 3 integers to be 1. That cannot work because we need X, Y, and Z to be distinct integers. So we can ignore this one. So the next cube we can test is 8. So if you take ABC, the product of A, B, and C to be equal to 8, we can find a solution for this with A is equal to 1, B is equal to 2, and C is equal to 4. So So under these conditions, we see that n cubed will be equal to 14 raised to 600 multiplied by 8. And under this condition also, we can get the cube roots of both sides, and we conclude that n must be 2 times 14 raised to 200. So that's the smallest possible value of n, because now that's the smallest cube that we have found, which works for this equation. And we can confirm that the three different divisors will just be n over a, which is n over 1, n over b, which is n over 2, and n over 4, which is n over c, which is n over 4. And that concludes but the answer we were looking for is this, 2 multiplied by 14 raised to 200. There may be a few other ways to solve this. If you put in a little effort, you might find other, maybe faster.
I have a question.
Yes.
Can there be a general formula for this? Because I'm seeing 14 to the power 600, I'm seeing the smallest divisor will be, the smallest value of n will be 2 to the power 14 to the power 200. I'm seeing 14 to 200 and 14 to 600. They are kind of related. So could there be a general formula?
Okay, what you need is, if the basic idea is that this was a perfect cube.
Yes.
Yeah. As long as it's a perfect cube, you can work with this. And therefore you are left, the remaining factor here must also be a perfect cube, otherwise it won't work. And therefore that means you are limited to, luckily we didn't have to test too many. The first two cubes gave us what we wanted.
Okay.
Yeah, so I don't know if there's general formula. You might find others where the first cube that works might be much bigger than 8, and that might take time. So I don't know if there's a general formula.
Okay, I'll research.
But the same ideas can be extended, yes. I have not thought of a general setup for this, but it's possible to generalize it and find some formal technique of solving this, which can be applied to many other problems. But if you dig deeper, you probably should find a different solution or a different way of solving from what I have used. One way would be to show that that product cannot exceed this 2 times 14 raised to 200. There might be a way to set up some upper bounds and show that that upper bound actually holds. So Trevor, you have seen the solution.
Yes, I've seen. I actually think I like this solution. It's clear.
It's clear. Okay. So this is the last question for today. So this one says Michoma picks a positive integer n which is divisible by 500. He writes down all the positive divisors of n except n itself on the board. So the task here is to prove that the sum of all odd numbers on the board is less than the sum of all the even numbers. So again, you can take some time to play around with this. So one way to look at it is if it is divisible by 500, what other numbers will it be divisible by? Smaller ones. If you work with smaller numbers, they can give you more ideas.
5.
Pardon?
5.
Yes, 5 is true, but probably not very helpful in this case. Maybe, but that's a general direction you need to follow. If you work with the smaller divisors, you can play around with some ideas. So 500 is basically a trick to make you think about 500, but that's not the number you should be thinking about. You should think about the smaller numbers. Any ideas? And also the other thing you should note that we are looking at all the divisors except n. So n is not included. Any ideas so far? So again, you don't have to go all the way. If you're able to solve it completely, that's perfect. But if not, you can just share the ideas you have, but to whatever point you have reached. Maybe someone else can complete. So maybe I can go to the solution. So here we will start on the solution. So now we've said that n is divisible by 500, and therefore it must also be divisible by 4, right? So this observation is useful for us. It's divisible. We shall use it at some point. So we also, because it's divisible by 4, we make the following observation. If D is an odd divisor of n, then 2D will also be a divisor of n. Can you see why? So for any odd divisor you pick of n, then 2D will also be a divisor of n. The reason for that is you can always pick 2 from the 4 and multiply by the D to get 2D, which is also a factor. Remember, 4 is a factor and D is an odd factor as well. So if you want to get 2D as a factor, you simply pick a 2 from the 4 and multiply it by D, and you get a new factor, 2D. So remember, we are not supposed to use the number n itself, so we need to be sure that 2D cannot be equal to n. And we are sure about that because n is divisible by 4 and 2D is not divisible by 4. So 2D itself will not be equal to n. So we are guaranteed that if we list down all the values 2D, none of them will be equal to n. Okay. So so we can do the following. We pair each odd divisor D with an even divisor 2D. So we know that this can be done because any odd divisor we get D, we can get a corresponding even divisor 2D. Now when we pair them like that, then we can do the following. If we add up, because definitely like D1 will be smaller than 2D1, D2 will be smaller than 2D2. So if you add up all the odd factors on the left, they will be less than these even factors. Now, these are not the only even factors, probably. There might be others. But now this guarantees us that the sum of all the odd factors is less than the sum of all of the even factors that are on the board. So that solves the problem that we wanted to solve, that the sum of all the odd numbers that he has written on the board will be smaller than the sum of all the even numbers that are on the board. And we can even go a step further and say it will be at least 2 times smaller. It will be at least twice as small as the sum of the even numbers, even factors on the written on the board. So that is the last problem for today. Has it made sense?
Yes, it has. It
is fine. So you can see how this 500 was a trick. If you were to focus on the 500, you might have trouble moving forward. So the 500 was just a trick to make you think that once you figure out that it's divisible by 4, then everything else falls in place. So again, today we were supposed to cover some topics in geometry, but I was held up with training for the Kenya team for the International Math Olympiad for the last 2 weeks. So I was not able to sit down and write notes for the geometry presentation. I think in the next meeting, we should be able to do that. So far, for the last few meetings, we have just been solving problems from the Math Olympiad type problems. Any comments from the audience? Now the floor is open for comments. No comments?
Hello.
Yes.
Hiyo invitation link ikitumwa kwa wall inasaidia sana. Last time I did
Yes.
not check the email.
Yes.
I realized when the training was over.
Yes.
So ikitumwa kwa wall the link inatusaidia sana kwa sababu hiyo ndio tunaiona when we are even busy.
Yes.
Thank you.
I will be consistent with that then, so that we get everyone to attend. And thank you also for showing up. You know, without anybody showing up, then I'll just be talking to myself here.
We are learning.
Yes, yes. Hey, Lawrence, you are very quiet, man. Say something.
Hello.
Hello, Lewis.
Yeah. So I don't for the last problem.
I put it back on the
I
screen.
don't know. Yeah, you can.
Okay. Yeah.
Yeah. So my thought process would be this problem. Yeah, it's almost quite similar to what you have. Although I haven't written mine down, but this would be my thought process. Since n is divisible by 500, then n should be divisible by 2, and that means that n is even. And if you look at if n is given, then the number of odd numbers that we have, that is to n, should be equal to the number of even numbers. So we should have the number of even numbers between 1 to n should be equal to the number of odd numbers between 1 to n. And if that is the case, if we could compare them like parallelly, so we could just have like 1 would be like we could compare it with 2, and then 3 with 4. So you can see that pattern, and then you'll notice that the even numbers would always be like the sum would be greater, because like the how can I say it, consequent numbers, you can see that or even numbers are greater than the odd numbers.
But you have not considered the factors.
Are of equal number.
You have only considered the
Sorry?
numbers. You've considered all the numbers up to n, but not the factors. We are supposed to only consider the divisors of n, not all the numbers that are smaller than n.
Okay. Okay.
You've seen
yeah. I've actually seen that. Yeah. Okay. Yeah.
But there might be a way forward with the same idea. There might be a way to polish it.
Okay.
I can't think of any now, but if someone else can think of some way to polish, they can share. But that's how you start. You know, you put together a few ideas, play around with them, see where you go, and keep trying. Is there anyone else with more comments?
Okay. Mine.
Yes.
I'll just say thank you for your time. And this is really good, because there's something we are learning. And I just want to, mine is just to thank you, so that now you continue doing the same.
Okay, I appreciate that. I'm always happy to do this. I will try to get more people involved. It's just that this is very time consuming, so people are busy, and this kind of mathematics normally requires a lot of energy sometimes. So But as we continue growing, we'll get more people involved.
Okay.
So and also as more and more people, we might extend this to also just cover some of the syllabus topics. Sometimes that can help to, some people may be interested in some of the topics covered in the syllabus, so that may be useful. We have covered some before, like the quadratic equations and some trigonometry as well. So maybe we should try to have some of those as well, and not just the Olympiad math problems. I don't know what you think about that.
I think that's okay.
It is also good.
Yeah, I think that one is very much okay.
Okay, we'll plan that. It's just that the last 2 weeks have been very busy. We would have covered at least some topics in geometry today, but I was not able to. So it was easier to work with solving problems and to prepare the presentation on the topics.
We are grateful for your tireless effort.
Okay, thank you. Also, I appreciate the audience. Thank you for showing up. Today, Alex has not said anything. So if there are no more comments, I think we can bring the meeting to an end, and we meet again in 2 weeks' time. So thank you very much for attending. You can now leave at your pleasure. If you wish to speak some more, you can still do so.